Hello guys, in this video, let's talk about selection sorting method in C++. Let's see a small introduction about the selection sort. So selection sorting method is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest element from the unsorted portion of the list and moving it to the sorted portion of the list. So in this sorting, we are traversing and finding the smallest element and swap it in the first place of the list. So we are traversing through the entire list and we are finding the small element and it is placed in the front part of the list, that is in the first place. So repeatedly doing this process, at the end of the selection sorting method, we will receive a final sorted order. So when we are starting from position 0, after sorting of the first element, we should start from the next element. So take the element I is equal to 1. So from index 1, we have to start and sort the second smallest element like the third smallest element. So automatically we have to proceed through a number of steps and finally we receive a maximum element at the end of the list and finally we receive a sorted element at the end of the list. We will see the process and working of that selection sort. So let's see the process and working of selection sort in C++ before moving on to the code. So I have taken a sample array of 62, 45, 32, 51, 80 and 17. So it is placed in the order I have given. So first of all, I am going to take a temporary variable minimum is equal to, I am going to take the first element. So 62, I am going to assume the variable as the minimum value. So first I am going to do, if 62 is greater than, if 62 is lesser than 45, uh, I mean, if that number is lesser than the next element, this number will get updated to the lesser value. So 62 is definitely greater than 45. So my minimum variable is now changed to 45. So now this is our new minimum variable. So this variable is now compared with the next element. So 32. So 45 is definitely greater than 32. So here 32 is the smallest element. So this 45 number is changed to 32. Now again coming to this, if 32 is lesser than 51. So obviously it is lesser than 51. So there will be no change in the element of minimum. So next checking with the 80. So obviously 32 is lesser. So the 32 remains unchanged. So moving on to the final value, 17 is lesser than 32. So this minimum 32 value is changed to 17. So this is the minimum value we are getting for the first least minimum value. So what we are going to do is change the move the minimum value to the first place of the array. So we have to interchange the element 62 and 17. So as I have said, we have set the temporary variable minimum is equal to 62 before moving on to the inner loop. So we are going to interchange this 17 and 62. So 17 will be placed over here, 45 will be here, 32 will be here, 51 will be here, 80 will be here, and 62 will be changed here. So this is the result of our first loop. So next we are going to omit this number 17. As we know that it is already placed in the correct position and the least element should be placed in the front part of the array. So after that, we should move from 45 to 62. So now I am going to fix the value minimum is equal to 45. So this will be even more clear when I will be explaining the code. So 17 is placed here and 17 is fixed. So checking from 45. So as you know that 45 is compared with 32. So 45 is definitely greater than 32. So this minimum value is fixed, and now the minimum value is changed to 32. So in the code, we will be fixing this as an I value, so that the first value is fixed for 45, and another value is being changed in the inner loop. So minimum value is fixed to 32, and now 32 is compared with 51, and 32 is definitely lesser, so it remains unchanged, and 32 is definitely lesser than 80 as well as 62. So our minimum value is fixed as 32. So we are going to now change from 45 and 32. So 45 and 32 is being interchanged. 32 and 45 remains interchanged, and others are remaining unchanged. So this is the result of our next loop. So in this loop, 32 is also being fixed. So moving on to the third loop. So minimum value is being fixed as, now again it is fixed as 45, and we are going to check it from next loop. So 45 is being compared with 51, so it definitely lesser. So minimum value is being fixed as, now for now it's 45, and 80 as well as 62 is definitely greater than 45, so it is being fixed. So both are at the same index positions. It is already in the correct position. 17, 32, 45 remains unchanged. 51, 80, and 62. So these three elements are placed perfectly. And now next loop is taking the 51 as the element I, and for now sake 51 is taken as position. So 51 is definitely lesser than 80 as well as 62. So it is also in the correct position. 17, 32, 45, 51, 80, and 62. So these elements are fixed. So moving through that, next minimum value is taken as 80 for now. So we are taking it as 17, 32, sorry, 32, 45, 51, and now 80 is being compared. 80 is being compared with 62. So 80 is definitely larger than 62. So now the minimum value is being taken as 62. So now 62 is being replaced in the position of 80. So 62 and 80. So all these five elements are done sorting, and you can see that as we have done all the five elements in the sorted array, obviously it is understood that the last element will be the largest element in that array. So 80 is also placed in the correct position. So this is the process and how it is working inside the selection sort. So I will be explaining the code now. So you can take this variable as minimum 1, or you can take this variable as temporary. Because for temporary sake, I have taken that element as 51 or 80 or 62. So element is fixed, and minimum element is found and replaced with that position. So the variable may be of any name. So it can be changed to minimum or minimum 1 or temporary. It is as you wish. So now we'll be seeing about the coding part. Now I will be comparing our working of the code with the actual code. So in the left side, you can see what we have done over here, then the process of the code. And this is our actual code. Now I will compare it with and explain it. So here we are doing and incrementing through two loops. So for int I is equal to 0, I is lesser than 6 minus 1, I plus plus. So I is chopped over up to the fifth element. I mean 0, 1, 2, 3, 4. It is going through up to 80, and the minimum one value is fixed at the index position. So minimum one value, what we are getting is 62. So this is where I fixed the value 62. In the previous, I have fixed changed it. So we are fixing the value as 62. And now we are moving through the next loop for int I, j is equal to I plus 1. So this is the int I value and this is the int j value as we are incrementing through a one value. So j moves through up to the fifth element. At the end of the loop, it moves up to 17. So reason we are giving I is lesser than 5 is I should be moving through 80 and j should be moving to 17. So if we are giving I is lesser than 6 and there will be no j value for to increment. So what we are doing through the inner loop is we are finding the smallest element in the array and replacing with the first element. So obviously, so now the j value is 45 and is 45 is compared with this minimum value 62. So 45 is definitely lesser than 62. So this minimum value first we have taken as 45. So the minimum value is 45. So we are moving through the next loop. So now I value is equal to 1 and we are moving through the next loop. So now 45 and 32 is compared. So 32 only is lesser than 45. Now our minimum value is 32. So 32 is compared with 51, 80 and no changes when we are comparing with 17. The 17 is the least element. So the minimum one value is equal to j we are taking. So the j value will be taken as the index value, uh, fifth element. So 0, 1, 2, 3, 4 and fifth element. So the j value is being taken as 5. So this three lines of the code int temp is equal to array of min. So this is the swapping of elements. So we are taking a temporary variable as array of minimum one. So array of minimum one is this we are taking is as 62. So 62, I mean sorry, this minimum one value is taken as 17. So 17 is replaced with array of I. So this value we have taken as 62. So 17 and 62 are replaced through these three lines of the code. Remember, this minimum value is being changed over here. So this minimum value 17 is being replaced with the array of I value, the first element of the value 62. So after this, it is being swapped 17 and 62. And through the next main loop, now the I is being incremented to 1. So 1 it is incremented. So this will not be taken into account. As a result, it is being fixed. Now our minimum 1 is equal to I. That line indicates 45. So next we are moving through the inner loop to find the second smallest element. So the 45 is compared with 32, 51, 80 and 62 through this uh, condition, and we are getting the final loop as at the end of the result we will get that second least element as 32. So now 32 and 45 are replaced and 32 is placed in the first index position. Since this is zeroth index position, first index position, it is being fixed. And next we are moving through the second. So now 0, 1, 2, 45 is being fixed and 45 is being fixed, and through the second loop the 45 is being compared and it is being unchanged. It is fixed in the same position itself. Now these three are fixed. Proceeding through all these loops, we will receive at the final sorted array. So we have received at the end of the loop 80 and 62 is being compared, so it is being interchanged. As a result, no need to proceed through the another loop, as we know that the last element will be always will be the largest element in the array. As a result, you will receive a final sorted order in this form after through passing through all the loops. So I will stop up to 4 over here in the main loop, and through the inner loop it proceeds through 17 and finds the smallest element and swaps with that least smallest element position, and we will receive the final sorted error. So this is how this code works according to this process and working. Now I will be explaining how this code will give an output in that using this code blocks. So here we are having the code blocks environment. So I have created a class called sorting, and I have declared some of the variables here. So this is the array of 6. The value I have explained in that process, and these are the variables I am going to increment. So here I have a void called selection sort, and this selection sort contains the code I have shown previous and explained it, and same code. So I am creating extra void called display. So this display will print all the elements in the array according to the how it is sorted at the end of the array. So I have created a main function. So it declares the variable, and this is being called over here. Now I will show how it will work. So this is the output I am receiving after running the code. I am receiving a properly sorted order as I have shown in the process of this code. So this is how this selection sorting method works. Let's see about the time and space complexity. The time complexity for selection sort is n square, since it finds the minimum element each iteration and swaps it with the first unsorted element. The time complexity is n square, and the space complexity is 1, since it does not require any additional memory proportional to its size. So the space complexity remains always 1. I hope that the process working as well as the code for selection sort has been made clear to you. Thank you for watching.